All right, my name is Jay Langston, and this is my final project for Python for data analytics. For this project, I decided to explore college football data from 2005 to 2016. The source of the data I got here from the name of the website is Dr. Wag's Picks. This is the website here, which we'll look at in a second. So here is actually a picture of the website. If we go to the actual website, I can probably show it a little better. So what we have is, it actually starts in 2003, but what I found out later was there's a lot of missing values in 2003, 2004, so I really just stuck with 2005 and on. So we have all the different years here in different CSV files, and then up here we have I guess the guy hasn't updated his website, so I'm assuming that he's going to do that probably this year. But here we just have the different weeks of 2016 broken down. So what I had to do there, this was kind of fun. So reading in the data from 2003 to 15, this broken down by separate years, was pretty fun. No big deal. I dynamically read them in by creating a blank dictionary. I used the time codes to print out when each year was done, when it was finished, and here's that happening there. But for 2016, as it was broken down by weeks, I had to be a little less creative, unfortunately. I had to actually copy every single link for each one of those files, and the reason why is I couldn't find a consistent way to read those in for each week. The easiest way the way to do it would be on the date, but you can see the dates aren't always 7 days apart. Sometimes they're 7, sometimes they're 6 or 5 or 8 or whatever, So I couldn't really do that in a creative way. But I was able to read them once I got them in there. I was able to read them all in and concatenate them to where they're one big file, and then insert them into the main dictionary for data frames for 2016, so it'll be in there with all the other years. Alright, so the next step here, I concatenated every single one of the files that was in the blank dictionary. So again, I left out 2003 and 2004 and just did 2005 through 16. So that's what I'm doing here, is concatenating all of those files into one. I renamed the columns so they'd be something that I would more easily recognize. And then here the final data set has 10,480 rows and 36 columns. And here's the first 5 rows, which didn't come out very good on the slides. But here are some more of the columns, so you can see some more of those. So what I did for each menu choice, I did 5 menu choices. Each menu choice is its own function. So here's just a brief preview of I'm just not going to go through all of them. Here's menu choice 5. I did a function that was linear regression. That's what that option is. And then within that function, I have a simple regression function that is much of the code that we use from advanced stats. And I tried to kind of, pretty up the output a little bit here. So I won't go through all the menu options because I'm already at a little over 3.5 minutes. So I'll go through options 1 and 5. So here's menu option 1. The t-test determined there's a difference in average points scored by the home team for 2 different years. This was actually a menu within a menu. So for this example, I did 2006 and 2016. And what prints out is a t-test report. First, we'll look at the equal variant, or determine if we need to use equal or unequal variances. Here, the variances are not equal, so we will use the appropriate t-test. And the conclusion here is we reject that the means were equal, so the means are not equal. And then it prints out a box plot here with the 2 different years labeled and their subsequent values. So I will skip over to, I have all the menu options here, but I'll go to number 5. Okay. So 5 is choose a variable to perform a simple regression to determine if it's a good predictor of home team points scored. So I just, so here's, I printed off the question so you know what it was, and then here is all of the different variables, which didn't come out well in the slides. And then this is, I used Seaborn to produce this scatter plot down here, and I use little plus signs as the indicator. But here I guess I chose home penalty yards was the variable I chose to perform simple regression on, and to see the conclusion was to reject the null hypothesis, and home penalty yards does help predict the home score. Okay, things I liked about the project. I really enjoyed reading in the data from the website and concatenating all of that. That was one of my favorite parts. Creating new variables, which I didn't really go through in the presentation, but I did. I had to create a lot of new variables to get some of those charts to come out on the menu options we didn't go through. I listed everything out, but no reason to go over all of it. I liked toggling on and off the code. And also, I need to get to this. I forgot to mention this earlier. I had a really hard time getting the slides to work with the raw code, even though I could toggle it on and off here. So here's my actual notebook, and I tried to create slides using this. So this is all raw code in here, or this shows the raw code, and here's all my menu options here, and da-da-da-da. But when I tried to make the slides, it just would not. I mean, I wrestled with it for hours, and I just could not get it to come out in the correct order, or I don't know if it was because the file was larger or what. But forgive me. But for this particular presentation, I used screenshots from that file I just showed you. So I used screenshots from this file, and then uploaded them into here so I could present them. So that was, I go over that here, things that didn't go smoothly. So I had trouble with that. Other than that, I really enjoyed the project, loved the class. It's my first time coding in any language whatsoever. So I really enjoyed it. And thank you for your time. And maybe we'll see you in another class. Thank you.